speaker. I don't know whether he's here.
Yes, we are all here.
Okay. So Fulvio, the floor is yours.
Thank you, Prof. I'm very proud to introduce the next speaker because I was lucky enough to be Omogolo's supervisor during his bachelor at BUST. So Omogolo Keobokile is a young Motswana from Tonota. He studied at BUST, his BSc in geology, and he worked in my team on a project in the Makgadikgadi pans, and a study that was one of the first considering the Makgadikgadi pans as analogs for planetary studies. So he applied to scholarship for his master degree through a project that is called the Pan-African Planetary Space Science Network. And he was awarded a 2-year scholarship to Copperbelt University in Zambia, where he did his Master of Philosophy in Geology, with a topic always related to planetary science. And today, I believe, is going to present what he learned and what he did during his research in Zambia on impact craters in Africa. It's very I really wanted him to present here because is one of the few young Botswana that are actively working in planetary geology. So I think he should be supported in this endeavor. And I'm looking forward to hearing from him what he discovered during his Master of Philosophy. Omogolo, the floor is yours. I think you have to share your screen.
Thank you, Prof.
Yeah, while he's sharing his screen, I must say that he's a very famous alumni of BUST, and he goes under the nickname of Chongololo. That's how everybody from UK to North America knows him in the field. Omogolo, can you share your screen?
Yes.
Harold, you have to stop sharing your screen, otherwise, okay.
Can everybody see?
We see your desktop. Go to the presentation, PowerPoint, and
Now you see what?
we see your screen, but not the presentation. Go to the PowerPoint and put it in presentation mode.
Give me 2 seconds.
Okay. No, it was fine. Go back to presentation mode.
Now?
No, we can still
nothing.
see your notes, which is embarrassing. Just get the
Oh, okay.
yes, don't touch anything else. That's perfect.
Okay, okay.
Okay, go ahead.
Good evening, everyone. Like Prof. Fulvio said, my name is Omogolo Keobokile. I'm Motswana. Oh, sorry. Good evening, good evening. Yeah, I'm Motswana, currently doing my master's in Zambia at the Copperbelt University. I'm currently in my final phase. I have submitted my thesis. It's under review. on the Journal of African Earth Sciences. So yeah, today I'm not really gonna be focusing on my topic because I'm in the astronomy now. So my paper is more focused on the geology form. So I prepared my talk as just a outreach kind of. Today I'll be presenting the geological significance and environmental impacts of crater formations in Southern Africa. Here's my outline for today. I'll be focusing on impact cratering, geological and astronomical significance of impact craters, approaches to uncover impact structures, craters in Southern Africa, and then lastly, a brief on my topic, which I was focusing on Lake Bangolu in Zambia. Firstly, impact cratering. Impact cratering is a dynamic process that shapes the surfaces of terrestrial planets, leaving profound marks on both their geological and environmental histories. This event, as you can see the illustration next, this event caused by the collision of asteroids and meteorites can alter rock structures, trigger climate shifts, and also display economic systems. So as you can see here, this is a small illustration showing when a meteorite hit a terrestrial planet, the results of altering rock structures and leaving, changing its topography. Also, not only does impact cratering have geological significance, but it also carries substantial astronomical value. The study of craters can offer insights into the behavior of asteroids and meteorites within our solar system and even beyond, and inform our understanding on how life may exist or have existed in other planets. Geological and astronomical significance of impact craters. Impact cratering is a key process in shaping the surfaces of not only Earth but other terrestrial planets and moons in our solar system. Here is a illustration of when a meteorite come in contact with a surface, leaving a ballot shape, as you can see, as it changes its topography. And as you can see, the picture below is one of the crater formations in Southern Africa, which is Vredefort crater in South Africa. In Earth, we have around 190 confirmed meteorite impact structures, and just only 20 are in Africa, but also 7 are in Southern Africa. Studying craters on Earth and other celestial bodies can provide clues about the presence of water or minerals. For example, the one in Botswana, it helped the country to find a source of water, as when meteorites come in contact with the surface, like I showed you earlier, that illustration. So hence it when it collide, it make a barrel shape, hence making feasible for subsurface waters to be available, and also minerals. In minerals, for example, the Vredefort dune in South Africa, is the largest gold. It has the largest and oldest gold mine in the world, and also the Subdu Basin in Canada produces nickel and copper because of meteorites. And also the environmental impact of large asteroids and meteorites collide can be catastrophic, generating shock waves that devastate ecosystem near the impact crater impact zone. This means when they come in contact with subsurfaces, mostly near the oceans, they can cause tsunamis. There's meteorites or asteroids, hence changing the ecosystem and the climate change. Now we look at how to approach to uncover those impact structures, because most of them are like Africa is covered mostly with sand. There's many like Safari, Kalahari. There's many deserts, so it's mostly hard to find this impact structure due to being covered by sand. So that's where modern technologies such as remote sensing. In remote sensing, we use satellite images, and also we use gravity and magnetic surveys in order to identify and study impact craters. But these ones do not confirm if it's indeed a impact structure. It just gives hints so that you can study more further. Field mapping and geology. As you can see, we have two types of impact craters. The simple and complex. Complex, it goes in hand with peak ring. So we have two ballot shape, which is just simple, like the previous illustration, or the complex one has a central peak. As you can see in the middle here, there's a peak and then ballot shape here. So in other impact structure, this can be an island on a meteorite impact. So sorry about that. After doing your research, maybe in the lab, in your office, using satellite images and gravity data, now it will be time for you to go to the field to collect those samples and then look into the microscope to see if there is any shock waves, which is petrography. As you can see, the third image, there's an example of planar fractures. As you can see, these lines here, this is a quartzite, a quartz. So as you can see, this shows that this sample here, it represents that indeed it has been impacted by meteorites impact, and also geochemistry. Craters in Southern Africa. We have 7 in Southern Africa, 4 in South Africa. This first one is the Kop crater, which is located in South Africa. As you can see, okay. As you can see, here is the crater, which is near, this is a river. And also we have this one here. This one is the Khagodi crater. These two are visible through satellites, as you can see. Even this one, the Louise, which is in DRC, they are all visible through satellite images. And also we have the Ratakam, which is in Namibia, which is in the desert, and also it's visible too. And also that's the famous one, the oldest crater in the world, and the largest crater, which is 225 kilometers, which is the Vredefort crater, which is located in South Africa. It produces gold. And also we have the Tshwaying crater, which is also in South Africa, which has a lake inside, as you can see. The other one, it's hard to see, this one, the Morokweng, is barely visible through satellite images. So, but also they drilled and found evidence of it being a meteorite impact. So coming to my project, I was looking at the Lake Bangulu in Zambia. Because everyone was curious, like out of nowhere, like there's a lake in the middle, like of the Lake Tanga, like there are many rivers in between, like around, and how did this one come about? So me and my supervisor went to the field to gather information as we used satellite images and geophysics, which is gravity and magnetic. They were not that clear, but also the image gives us a features which is almost resembling a impact structure. So hence we went to the field to correct some rock samples and went to the lab to analyze to see if there is any shock waves which will indicate meteorites impact, or also the geochemistry which will give any signals as if like, is there any extraterrestrial chemical on those rocks, like comparing them with normal rocks and comparing with the ones I took from the Bangolo to see if there is any abnormal figures. But in conclusion of my research, there was no any shock waves or shock metamorphism on the rocks or any signs of the extraterrestrial chemical signatures on the rock samples, hence concluding that Lake Bangolo shows no presence of any impact structure. Thank you. Hello?
Thank you very much. I don't know whether Fulvio is still around, can lead us on the questioning.
No, Fulvio is not around. Prof, if you can lead the question and answers, it will be good.
Why am I not
Oh.
around? I'm here.
Oh, okay. I saw a message saying that you won't be around. Sorry.
Yeah, but you go
Sorry,
ahead.
Fulvio.
It's fine. No, it's fine. Go ahead.
No. You can because you are knowledgeable in this area.
Yeah, stop sharing your screen, Omogolo. There is a question in the chat. How can you tell from the sample that there has been meteorite impact? What do you observe and learn from the samples you collect?
Okay. Thank you for the question. Looking at the geochemistry, there are hydrophil elements. So hydrophil elements, they resemble a meteorite impact. They give signals to that indeed this is a meteorite impact. So in the geochemistry, we look at those, we are looking for those elements, and also I'm trying to look for any image. Give me 2 seconds.
Yeah, you should put your image in the presentation, eh?
Yeah, yes, sir. I'll correct myself next time.
What about shocked quartz? Tell about that.
Okay. Yeah.
What?
Hold on, I wanna share again the screen.
Oh, okay. Okay.
Okay. So here, this planar deformation fractures. So this image here shows that indeed this has been caused by a terrestrial like meteorites and cosmics. And then this one is from Quebel 20. I got it from one of the articles. And then on the other side, this is from my rock samples. So this is a quartz and also this is a quartz. So as you can see, the two, like the figure D on my, as you can compare the two. So here you see this linear here. They show that indeed this has been, which word? I can say maybe impacted, like broken down, or maybe something fell on it and broke, just like where you take a plate and you break it and it breaks differently than the other. So this one here shows that indeed this was because of a meteorite impact. And from mine can be a fault or just then, but mine is just the normal quartz, normal quartzite. It doesn't show any signs similar to this one's. Hence me concluding that my samples don't have any kind of these features. Yeah, thank you.
Okay.
I have a question.
Yes, go ahead, Prof.
Yes, please.
Oh, okay. I think I heard you mention, and the speaker mentioned that the crater found in Botswana
Yes.
has water sort of is a source of water, or has been drilled, I suppose, for water supply. Can you explain how that water is in there? Is it in fractures or is it in the rock formation? I mean, is just kind of brief us what actually is causing water to be there?
Okay. Thank you for your question. Like I said, from my first, like, you know how when when an impact happens, as you saw my illustration, how it occurs. So not really does the meteorite or produces water, but hold on. Let's say, for instance, here, this is Botswana, so the meteorite came in contact with the surface here. So people can assume that there was water underneath, but this impact here made the water to come near. It was like subsurface, the water. So now when this impact happened, it made the water to be near so that it can maybe like go out, you know how boreholes and all that occurs. So the Botswana survey, they were drilling around Botswana looking for water sources. When they went to Kagodi, they found out there's indeed, they took the rock samples and went onto the lab to make more further detailed studies. That's how they found out that indeed this is a crater. That's how they found the water and also they found the crater. I hope I answered your question.
No, you did not, Omogolo. You are beating around the bush.
Can you please
Any
rephrase
other
your
question?
Yeah. Well, I mean, that's okay. Maybe he hasn't actually studied it himself. But that's okay. I was just wondering how the water got to be there. But if that is the explanation, then yeah, it's okay.
Thank you for
So
your
I don't
question.
know. Yeah, I don't know whether there
Yes.
are any other questions.
I see someone is
I
typing.
have a question.
Gian?
I have a
think.
question, Omokolo.
Yes, please.
Yeah.
Omokolo, you did mention the South African crater and the Canadian crater being very rich in gold resources and the other in nickel and copper. And out of the 7 craters in southern Africa, do the others also have mineral resources due to the impact from outer space? Is it a norm? That's my question.
Okay. Thank you for your question. Looking in Southern Africa, only that one. But in Canada, there is that one I also mentioned. And also in Russia, there are 3 which produces diamond. But the ones in Southern Africa, that's the only one. So, yeah.
Okay. Are there any other questions? Yeah, I think if there are no more questions, I would like. I was just looking at the chat here. But I think you have answered those questions on the chat, haven't you?
There's another
Yeah.
question that has come up on chat.
Okay. Are there
Yeah.
any water-bearing objects? Please, Omogolo, can you help us with that one?
Yeah.
Can you see the question?
Okay. Yes, I can see the question.
Okay, yeah, just help us with the clarification there.
Thank you for the question. From my knowledge, no, they are not, but I'll look more into it because I might say no, but maybe they are. I haven't really much went into that direction. My focus mostly was to find either is it a impact or is it not an impact.
What question are you answering to?
Are there any no water bearing objects in the asteroid? In the comment section.
The answer is no, Omogolo.
Yes.
Okay. So I think we have come to the end of this talk. Looking that maybe there are no more questions. I think I would at this point like to thank Omogolo for sharing what he has been doing and some insight into the formation of craters. So with that, I think we have come to the end of tonight's presentation. Thank you very much.
Thank you for inviting me.
Thank you, Omogolo.
Yeah, so yeah, that brings us to the end of the presentation section. I think will be the committee members will stay on or move to another site for the committee meeting. So thank you very much, the audience.
Sorry, Chair.
Yes.
I'm sorry to disturb, but it seems like we have a raised hand.
We have a raised hand. I didn't see that.
I think so. It's
okay.
LP. Who's LP?
Okay. I'm not seeing everybody here, so
No, I think maybe it was me. Was it me? With a raised hand.
Oh, maybe it was you.
Yes, I wanted to ask what is the significance of knowing if a crater was made by meteorite or something else, just to get a little background why it was very important to do the research. Thank you.
Omogolo, can you help us with an explanation or an answer to that? Your microphone is muted. Oh, I hope he has not left already. Oh, yes, please,
Okay.
Omogolo.
No.
Go ahead. Yeah.
Okay. Thank you for your question. Like I was saying from the beginning, it's important to know what's the cause of something. So, for my research, the loopholes, the gaps, the questions, it was either was it a impact crater, or maybe it was caused by the East Rift. So for me, I wanted to, because it was an enclosed case. It was not closed. So I wanted to know if, was it caused because of the rift, the East Rift, or maybe an impact crater, or maybe just tectonics. So we wanted to come up with the conclusion that, is it a meteorite impact or is it not? So my focus, like Prof. Fulvio, when he was introducing me, I got a scholarship which was focusing more on planetary geology and space science and astronomy. So I couldn't drift away from their aim and their motto. So my focus was more of either approving if it was a meteorite impact or not. So that's how I came about to do my study. And also it's important because, like I said, economically, if people didn't discover the Van How in South Africa, the Vredefort in South Africa, no one would have known if it's a crater or it's not a crater. And also, where did that diamond come, that gold come from? Because that's the largest gold in the world. So it's important because meteorites come with their own elements, their own chemical and also impurities. So those impurities can, when come in contact with subsurface, they alter the rocks and create new rocks. So yeah, it's important. I hope I answered your question. Hello?
Yeah, yes, you did. Thank you. Thank you so much.
Yeah, thank you for your question. Thank you, sir. Chair.
Maybe while we are waiting for the chair, I may also add, if you don't know that it's an impact crater, then that gives you a data source where you can get an idea of how craters evolve in different conditions. And also, as you are saying, these are chemical signatures that different asteroids and meteoroids may have. They can be useful in also trying to assist in learning or getting information on the origin of those objects. Just to add on. Thank you very much.
Thank you for your comments. Yeah, I think we should bring this to a conclusion. I don't see any more questions on the chat. So I'll just thank the speaker, Omogolo, and the audience for participating in this presentation. So I think we'll be having another one at the end of the last Thursday of February.